Hello, friends. I'm Vivek Naik. If the organizers have missed it, I would just like to introduce myself. I'm past president of Indian Concrete Institute and managing director of Apple Chemie. We are here at India Construction Week 2020, and this is a great thing which is brought to you by CIDC. And I would like to congratulate the organizers and especially Dr. Sarup for giving me this opportunity to be with you. Today, I'm going to talk to you about precast works and jointing of panels. See, precast technology is very much there, and it has got its advantages, disadvantages, and challenges, which we will discuss this in a short presentation. If you see the history, historically in 18th century, way back around so many years back, I think thousands and thousands of years back, in the Western world, in the Europe, there were some challenges, and to meet out those challenges, they found that construction over the bridge and over the bridge having one more aqueduct. So this is a very typical, very old picture. But during managing this challenge, what the construction people thought that time that it will be better to cast large sections at one side in Surkhi mortar, cure them, then transport them to the site and install. And I won't say fully that this is a precast structure, but this is the structure where large pieces were brought together and they were aggregated to make this structure wherein at one level you have an aqueduct and the other level you have a road bridge. That is the international scenario and historical stage. If you see the Indian scenario, the precast in 1939 to 1943 in Chennai, Nepai Bridge was constructed, and it is constructed with precast and pre-stressed technology. And even before that, 1905 to 1910, Madras Port, they cast so many piles and other elements, even the long retaining wall, and the wall is to the length of around 6 kilometers in precast segments and put it there at the place. So you can say that precast has come to the life to meet out the site challenges. We construction engineers thought that why not to cast a piece and then take to the site and just install it, so that in situ work can be avoided. And then it went on developing, and then there are further developments which we will discuss further. So if you see overall precast concrete system as such, what you do is first the concrete, which is the basic ingredient obviously, but in precast concrete, the concrete is designed to have a good demolding properties. Most of the time it is demolding time which is important, because the mold is reused and the repetition of the mold carries the essence of precasting technology. So quicker demolding is one parameter, so you need higher early strength. So also you need lesser of a curing time, or there are some dry mixes which are used, and then you demold the product and then you put it for the curing, whether it is a steam curing or water curing or any other form of it. And the third aspect when you design concrete is what finish you want after the concrete comes out of the mold, after the concrete is on the side. That is the aesthetics and the finish. So you can be having various molds, and on the molds you can have so many designs, inlays, or whatever texturing, so that the final product is having that look. Coming to the molds, where the precast concrete is put in, is you can have molds in steel, we can have molds in aluminum, you can have it in FRP, PVC, and many other materials also. as far as the handling is concerned, uh, you design concrete for initial handling, that is removing the concrete from the molds and putting it in the yard. That is first stage. And the second stage is you handle it with crane, put it in the flatbed trailers, or transport it to the site, stack it there, and all those handling parameters. So that is how you do the handling system in the precast works. The most crucial in this discussion, where I am going to give a little more emphasis, is the jointing of precast segments, wherein we talk of jointing technology and jointing materials, and obviously the finishing systems. So hereafter, what we give more emphasis is the overall system, but the focus will be on the jointing materials and jointing technologies. Well, as we have seen that why precast? Yes, this is a comparative study, and it is sourced from some international manuals, and this is just brought in for you people for the understanding that when you do cast in place work, comparatively you save time and money. And then you have steel and precast composite work, then you save little more of it. And you want to save more is steel and directly brick work or block work, you save further time. And precast is the technology which will give you work at a very high speed and maximum of the cost saving. This has been proved, and that is why today we are talking about the precasting. Most of the time in India and in the part of the world, low cost housing is a very common phenomenon because it is a repetitive job. You do housing on a very, very large scale on in large tenements, and you can get the benefit of precasting technology. But not only limited to the housing, there are varieties of precast structures. That underground structures can be in precast, foundations can be in precast, tunnel segments can be in precast, various wall panels and retaining walls can be in precast. Housing, yes, we have already talked about it. Infra buildings, larger scale infra buildings can be in precast, and not last but the least, even the reservoirs or tanks can be very well done in precast. Just you have to take care of the joints. I will just run through some of the pictures. This is about a precast work underground, and this the right hand side is a precast barrier. These are the barriers which normally you are using for the by the side of highways and roads. So also precast manholes and tanks are quite liberally used, and they give you quite a lot of speed and higher quality. Precast roads, you say how many? Yeah, I'm not sure, but in mostly in every country these days, you will find that they have done some precast roads here or there, at least somewhere 4 5 kilometer, 10 kilometer trial roads are done, and uh, they have been found very successful. The most important part again is very good quality and in very short time. There is a challenge, friends, when you are doing precast roads, that the subbase has to be very, very good, and the base preparation. What I mean, a fully leveled base is very, very important. That is why what you can see in the center of the screen, there are shims on the road, which is a leveling mark to what extent the fill can be done. And to your right, you can see the shims are fully embedded, and the stone dust or any other subgrade is put flush with that. Now, as you have got a leveled base, you can put your panel on there. If there is a little bit of a deviation in this, then you will be finding cracks, and then there are a lot of challenges in the road segment. Next is that when you are done with the road, there can be many culverts or underpasses below the roads, or larger pipe segments where precastings can be used. Precast boundary walls and retaining walls have been used from quite initial stages, and today also we are using it. But now people are going in for new designs uh, and new textures in the precasting things. Looking at the methods of precasting and the systems, one thing is you have a large panel system wherein you are doing large infrastructure elements like factories and buildings. You have a big segment, you cast it and put it into the place. So that is one. In this system, there is a large modules. Large modules are there, and these large modules are cast in one go. You have got the entire block of maybe an apartment, or at least one or two rooms, or even the service blocks. Because what gives you a benefit is, if you look at the overall construction, friends, that when you are doing a building construction, maximum time is spent in service area, because in the toilets and washrooms you have got electricity, water, service lines, plumbing, hot water, cold water, so many things. But if you have got all the things already embedded in the service block, and the service block is made ready with the sanitary fittings and brought directly to the site, it saves a lot of time and it carries a lot of sense in doing the work that way. So that is one plus point of precasting. About the columns and beams casting, yes, you can do the column casting at one place and just install the column. These are the columns of heavy industries, and then you can grout them. Again, the connection of precast column with the foundation is quite crucial, and the grouting will come down to that particular part of it in future. Precasting, wherever these connections are avoided, especially in the smaller buildings, mostly what is useful is footing plus column. So you have a stub column and a footing, everything put together. It can be cast together, and then you shift it to the side, and that gives a benefit. Staircase is a quite critical element of precasting, and you can do it in the one, two or three elements and directly install it at the site. If you are talking about the joints, yes, there are a lot of codal provisions, ISBS and ASTM codes, which tell you how to design the joint and which materials are to be used. That you can definitely peep into the codal provisions. I am not discussing that here, but what I am discussing here is the challenge and how to make the practical challenge. See, the joints can be categorized basically into the vertical and the horizontal segments, and then you have a mechanical connect between the two joints, and then you have sealants and adhesives and the protection coatings, and the protection strip seals are coming on the surface, which is, we can call it as a weather strip, or and then the sealants are polyurethane sealant or silicone sealant and many this is one out of it that you have. If you are talking about jointing material, it is a sealant, packing, and grout. This is how I categorize. Packing is something, a filler and a flexible media. Sealants are there to stay on the exterior side of the joint, and there are grouts which are used at the installation stage. And this is what we have is a segment of a precast segment of a road. Maybe these are large segments of around, at the top it is around 24 meters in width, and these segments can be cast and just put it at one place, and you can make it a flyover or a bridge. And what is crucial is segment bonding adhesive. When you put two segments together, you need to cover the entire surface area which is coming in contact. So normally this is 2 to 3 millimeter, even less than 3 millimeter. And then you squeeze the two segments and the jointing material comes out of it. That is obviously at the time of post-engineering. There is one very, very typical thing I have seen is coupler grouts. Coupler grouts are the grouts which are not very carefully looked into by the construction industry. And that is why I think I wanted to stress this here, that let's go a little further. We're saying, see, if you are talking about the precast construction, what I said is accurate casting, safe transport, careful installation at the site, and precast jointing. And the joint is the key factor. Why I'm saying joint is the key factor? Very recently, in 2011, in San Antonio, Texas, where when there was an earthquake, almost all the structures which collapsed and the collapses pertaining to the precast were at the failure of the connections and failure at the joints. May it is in the column or at the base plate or even PV structure, everywhere they were in the joints only. And this very well tells us that we need to focus and be more careful at the joint when you are talking about the precast technology. This is a typical scene when we noted that improper grouting was done at the joints and the joint plates. Uh, Going further, what you see is the precast joint at the foundation level, wherein you have dowel pins coming up and you put your column on the top of it, or you have a coupler which is added here. That is quite clear from the screen. Similarly, you have a foundation where you can have a column which is either smooth, then you put a column, put it into the groove of the pocket foundation, or you have a rough pocket foundation and you again put it into. Both the systems are used, or the lower part of your screen you can see it is at the site installation where a larger piece of concrete is cast to install the precast column. This is what the coupler I mean. These are the couplers and the extending pieces. These are used for the extension of and the continuity of the reinforcement. And there are various uses of it. You can use it in the infrastructure, like what I have shown over here. This is a huge column and the beam connection or vertical connection also. These couplers can be tested in the laboratory, and the grouts which are used in the coupler are even more important because the coupler basically is a mechanical thing and it can be tested for various mechanical parameters. And what I have shown you here on the screen is this coupler, and you put the other piece of this reinforcement into the coupler. Before that you are grouting it. The coupler is fully grouted, and then you put the next portion over here. So this is what I have shown it here on the left hand side of your screen. Allow this to set, then you test it. If you splice it horizontally, what you should see, what you should see ideally is the right hand side portion. This is what I mean. The grout around the rebar should be absolutely full and total. So that shows a full grip. If you cut the splice, right? So this is to be done mechanically by force. And the other part of the testing the grout is you can put it into the testing machine, tensile failures, which you see. And if you go in for the tensile failure, the failure should be in the parent material. Obviously, it should be in the rebar and not in the coupler section. Well, so this coupler section should remain intact and the failure should come here or here, whatever it may be. And there are various technical parameters in the graphs and all this. I'm not going into the depth of it, but that is what it is. In the laboratory, we definitely check up. This is only a test piece. Those don't go by this, why there are so many openings. This is how the test piece of the coupler is put, and you check up what is the requisite length of the coupler required for a particular diameter rod and for particular strength. It's a design part of the coupler, and then you use it. But my main interest and the concern point is how you use the installation grout. Um, See, there will be manufacturers. This is one of the best manufacturers. As yes, they have said that it will be pre-mix, non-shrink, free flow, high strength panel grout or joint grout, and there will be a test certificate or a manufacturer test certificate. what is our duty as a consultant or a construction engineer? That you get it tested through NABL accredited laboratory, verify the test parameters, verify the